This is known as BPT, Basic Proportionality Theorem, or BPT, also known as Thales Theorem. So the definition of this theorem is given in the textbook, so I will not write it here. I will just explain the theorem and prove it. The proof of this theorem is important because sometimes in exams you are asked to prove the theorem and also its converse. So both are important, the theorem and its converse. ABC is a triangle and DE is a line which is drawn parallel to BC. Okay. So if DE is a line drawn parallel to one side of a triangle BC or triangle ABC, DE is parallel to BC, then it divides the other two lines in the same ratio. That means AD by DB is equal to AE by EC. That is the theorem. If a line is drawn parallel to any one side of a triangle, DE is drawn parallel to BC. Okay. If a line is drawn parallel to any one side of a triangle and it intersects the other two sides at distinct points like D and E, it intersects at D and E, then it will divide the two lines in the same ratio. Okay, that is the BPT, or Basic Proportionality Theorem. It is also known as Thales Theorem. So we have to prove the theorem. To prove this theorem, we will use area of a triangle. What is the formula for area of a triangle? It is half of base into altitude, right? This is the formula. Area of a triangle is half of base into altitude. DE is drawn parallel to BC. It is given. Let us draw EN perpendicular on AB. Okay, and join BC. EN is drawn perpendicular on AB and BE is joined. BE. Then we have this triangle. ADE is a triangle. This one. Area of triangle ADE. What is the area of the triangle? Half of its base and altitude. What is the base of ADE? ADE. Any side can be taken as base. We take AD as base. And if we take AD as base, what will be the altitude? The perpendicular drawn to the base from the opposite vertex. E to EN. Right? Half of base into altitude. Area of triangle BDE. This is also a triangle BDE. So what is the area of this triangle? Half. Let us take BD as the base. If BD is the base, what will be the altitude of this triangle? It is EN. Let me explain. This triangle is like this, right? B, D, E. This is an obtuse angle, more than 90 degree but less than 180 degree. So in this obtuse triangle, how do you find the area of the triangle? You extend the base, then draw a perpendicular from the opposite vertex, then multiply half of base and altitude. Base is already BD. What is the altitude now? EN. EN. Right? In obtuse triangles, we find area like this. Okay, we can extend the base and then take the altitude like this, drawing a perpendicular to the extended base. Okay, this side is done. Hence, area divide this to area of AD by area of BD, half of AD into EN divided by half of BD into EN. This cancels out. We get AD by BD. Okay. So area of AD, area of BD is AB by BD. Suppose this is 1. Again, draw a perpendicular from D on AC. DM is perpendicular on AC. Let us draw okay. And join CD. Let us join CD. Hence, area of triangle AED is equal to half of this triangle AED. What is the formula? Half of base. Let us take base as AE. What will be the altitude? Now the altitude will be dm because dm is perpendicular on AC. Right? And area of CED, this triangle CED, this triangle. Again, this is similar to BDE. Base is EC, half of base. Altitude. What will be the altitude of this triangle? Similar to BDE, its altitude was EN, and this triangle's altitude will be DM. Hence, area of AED, which is also equal to ADE, it is the same triangle. Area of this one divided by this one, half of DM. Cancels out, we get AE by EC. Let us say it is number 2. So we have area of ADE, area of BD is equal to AB by BD. Area of AED, area of CED is AE by EC. Now triangle BDE and triangle CED share the same base. Suppose this is the base DC, DE is the base, then this triangle and this triangle share the common base DE. Common base DE. If you take DE as the base, then it will be the common base of this triangle and this triangle, BDE and CED, and are between same parallel lines. It's continuing here. Okay. So these two triangles BDE and CED they share the same base DE and are between the same parallel lines. DE is parallel to BC. This line is parallel to this line. So if that is the case, then area of triangle BDE is area of triangle CED, right? If two triangles are share the same base and are between same pair of parallel lines, then their area is also equal. So we have from these two relations, this area of BD is equal to area of CED, and area of AD is already equal to area of AED because they are same triangle. and triangle ADE. ADE is AED, same triangle. Triangle. Hence, this one is equal to this one. Numerator is equal. Denominator is also equal. So left hand side is equal to left hand side. So it follows that right hand side is also equal to right hand side. Hence, AB by BD is equal to AE by EC. This one. Okay. So the theorem BPT or Thales theorem is proved. A little bit of modification here. We have to mention these relations from 1. Hence from 1 and 2. This one AD by DB is AE by EC. Hence proved. We will prove the converse of BPT. Okay. The converse is given on your textbook, so I will not write it again. I will just do the proof of the converse. So the converse says that if a line in a triangle ABC, if a line DE divides the two lines in the same ratio, then it is parallel to the third side. Okay, that is the converse of BPT or Thales theorem. So we have to prove that DE is parallel to BC. This is what we have to prove, is parallel to BC. So let DE intersects the two lines at D and E. AD by DB is equal to AE by EC. This is given. AD by DB is equal to AE by EC. We have to prove the converse, that they are parallel. These two lines are parallel. That is what we have to prove. So this is the given condition. It's given. We will assume that there is another line parallel to BC. Suppose DE is not parallel to BC, so there must be another line which is parallel to BC. Okay, we are assuming that DE is not parallel to BC. Suppose this is the line. Okay. is parallel to BC. This line is DF is parallel to BC. We are assuming. Hence, AD by DB is equal to AF by FC. BPT, Thales Theorem. Thales Theorem tells us that the parallel lines, okay, when a line is drawn parallel to one side, then it will divide the other two sides in the same ratio. So according to by BPT or Thales Theorem, this is true. AD by DB is AE by EC. This is given. This is given already. So these two are equal. Hence, from 1 and 2, AF by FC is equal to AE by FC, right? This one is equal to this one. Now let us add 1 to both sides. Let us continue it here. Okay, then we get A by FC plus 1 is AE FC plus 1. A by FC plus 1, AE by FC plus 1, which implies AA plus FC is AE plus FC by FC, right? What is AF by FC? AF plus FC. AF plus FC is AC. AF plus FC, this is AC. AC by FC. AE by FC. Mistake. Let me correct it. AD by DB, AEEC, FC by FC, AE by EC. Yes. So we add 1 to both sides. We get it here. EC by EC. So AE plus EC, AE plus EC is AC again. Which means this is equal, this is equal. FC is equal to EC. So FC is equal to EC. Okay? Hence, how is it possible? When F and E coincide. This is possible only when F and E coincide. These 2 points are the same point. Only then FC and EC is possible, because both of them are on the same straight line. And if FC is equal to EC, then F and E must coincide. Right? Hence, and if F and E coincide, then hence DF and DE must be the same line, right? These two coincide, so DF must be equal to DE, and since DF is already declared as parallel to BC, sorry, yes, if DF is parallel to BC, that follows that DE must be parallel to BC. Hence parallel to BC, and we have proved the converse of BPT. To recap, it is given and let us assume that we have another line which is not parallel, which is parallel, because DE is assumed to be not parallel to BC. So there must be another line DF which is parallel to BC. Then AD by DB is equal to AF by FC. Why? Because if this is the parallel line, so it will divide these two lines in the same ratio. Okay, but we already have this one, AD by DB is AE by EC, it is given. So we compare these two, we get this side is equal to this side, which means AF by FC is equal to AE by EC. Then we add 1 to both sides like this, we get AF plus FC. AF plus FC is equal to AC by FC. Then again AE by EC, AE plus EC is the whole line AC again, so we get AC by EC. So AC is equal to AC, so FC must be equal to EC, right? And that is possible only when F and E coincide, they are the same point, because both are on the same straight line, and if they are equal, the segments are equal, they must be the same point. So DF and DE must be the same line. If they are same point, then they will coincide with each other. DF and DE are the same line. DF and DE must be the same line. So DE is parallel to BC because DF is already parallel to BC. We assume that DF is parallel to BC. So DE must be parallel to BC. Hence the converse of the theorem is proved. So in exam sometimes you may be asked to prove the converse of the theorem, okay, but the proof of the main theorem is very important. So remember that, practice that, and in the next class we will do some real application, some application based problems based on these theorems, the main theorem and the converse of this theorem. This converse of this theorem will also be required. Okay, and we will also discuss about other similarity criteria for triangles, because this similarity criteria are derived from the BPT, the Basic Proportionality Theorem. So we will discuss about that also, and we will also do some problems based on similarity criteria. Okay, so let us stop today.